Hello, this is Dr. Satish Singhal, PhD, Professor of Computer Science, and I want to talk about logical operators in C#. They're the same in other languages. So this is really selection control structure in C# Part 2. So basically, what are logical operators? While 6 comparison or relational operators operate on non-Boolean data type, every data type other than Boolean, the logical operators only operate on Boolean data type. Operate means they can combine operands together. There are 3 logical operators: and, or, and not. These are the names in words. Programming language, we do not use these words. We use symbols. And or are binary operators, which means they'll require 2 operands, one on left and one on right. Anytime we talk about binary operator, they will have 2 sides like 2 hands, one on left, one on right. Not is a unary. Requires only 1 Boolean operand. Just remember simple computer science rule. Any binary operator requires 2 operand, one on left, one on right. A unary only has 1 operand. Most of the time, operator is on the left, operand is on the right. But of course, there are some variations on that. Okay. And what these are, their representation may vary a great deal between programming languages. Let's talk about AND operator. AND is a binary logical operator. Requires 2 Boolean values at operand, one on left, one on right. Imagine the Department of Education wishes to give scholarship to young students. Okay, so we are getting into the situation that where AND operator may be applicable. Criteria they choose is that the student age should be under 17, but their GPA up to that point in high school or whatever should be greater than 3.8. If both are true for a student, then a student gets a $200 per month scholarship. And next slide shows how we can do this using a flow chart. So we can do it this way, that we can start, read student's name, age, and GPA, 3 things. Okay, read name, age, and GPA. And then we test for age. If age is less than 17, if that is true, then we do a second test that GPA is greater than 3.8. And if that is true, then print student's name, write scholarship granted message. But age could be more than 17. If that is false, then we ended the program, because in that case we do nothing. But if age is true but GPA is less than 3.8, then also we don't do anything and we get out. So this printing student's name and granting scholarship is only done if this is true and this is true. Both are true. So notice that we have nested an if then else. Actually, we have nested 2 ifs. Inside this if we have another if, and that nesting becomes clear by the pseudocode, that if age is less than 17, then, and the second if is inside the first if. Okay, so that's the flowchart and pseudocode for this program. But what if we can do test for age and GPA both at the same time. That will certainly avoid nesting this if inside the other one. And operator allows us to do exactly that. And simplified flowchart using that and operator is shown here. Both condition, age less than 17 and GPA greater than 3.8 must be true for the true branch to execute. And that's my flowchart for that. That I read student name, age, and GPA. And then I do this test, combined test using the AND operator. That if age is less than 17 and GPA is greater than 3.8, if both are true, then I do this. If it's false, then I do nothing. Okay. If both are true, I print student's name and say scholarship is granted. So AND operator allows me to make sure that both conditions are true. Okay. So what has to happen is that AND operator has to work like this. Consider age is 18 and GPA is 4.0, this scenario. So in that case, age less than 17 is false. Although GPA greater than 3.8 is true, but AND operator must behave in a way that if this is false, the net result is false. Okay? Then let's take the second scenario that age is 16 and GPA is 3.7. So in that case, this part is true, but GPA 3.8 is false. So that means the AND operator must behave in a way that if this is false, then entire thing is false. And then AND operator should also behave in a way that when age is 19, then this becomes false, and GPA is 3.7, then this both becomes false. So in that case also the net result should be false. Only when age is 16, this becomes true, GPA is 3.9, then this becomes true, then AND operator should work in a way that this becomes true. So AND operator, this is giving us conditions for AND operator, that when operands are combined by AND operator, it should only give a result true when all of its inputs are true. Okay? So how should it work in the circuit? We want to get some idea of that. How should it work in the microprocessor? After all these things are built inside microprocessor. So we give a diagram for that. Okay. In programming language, the AND operator is not represented by the word AND, rather is represented by two ampersand symbols like this. Visual Basic uses the word AND like that, but we will not worry about that right now. So this is the symbol for AND operator. And its electronic analog is shown like this. So electrical analog of AND operator that is actually built, manufactured in hardware is here. We're showing two inputs through these switches, X and Y, and a bulb. So translation of the circuit diagram is as follows. When switch is unconnected, it's considered a Boolean false value. So both switches are in false state. And the bulb represents the state of X and Y. And when bulb is off, that's also considered a false state. Okay. So right now the way circuit is, Boolean X is false, Boolean Y is false, as X and Y is false also. Okay. But if I close both switches, then bulb will light up. So when this is true, bulb is X and Y is true. Notice that if I make one of the switch true by closing it, true, this is still false, bulb still won't light up. So X and Y will be false when only X is true and Y is not true. And the reverse is also true. If this is open, this is closed, still bulb will be false, bulb will be off. Okay. So this gives rise to this truth table that if you have two operands to a and operator, then when X and Y both are false, X and Y is false. And if my voice seems a little tortured, I can show you again. False, false, bulb is off, false. Okay. But if you make one of them true and keep other false, either here or here, it still remains false. And we can show that here, that I can close this, but current still doesn't flow through here, so bulb remains off. And if I leave this open and close that, same result. Okay. Only way bulb will light up will be when both are true. And this is true, this is true. So both inputs have to be true. For X and Y, this input has to be true, this input has to be true. Only then it will work. Again, this is given as a visualization aid. In hardware, it is accomplished using transistors. Those of you for whom this is something new, please study more. Okay, convince yourself that this is true, and it will be. So this is the truth table for AND operator. Okay, so that's one of the logical operator, and in C# is represented by this and symbol, ampersand symbol. Okay. Second operator is called an OR operator. And it also takes only Boolean data type as its operands. Imagine, so now we are just, first I'm showing the application and then later on the truth table for OR operator. Imagine that insurance company gives bonus to its agent based on following criteria. That if you sold 100,000 worth of insurance in a week, or sold to 20 new customers in a week. So if either one is true, it gives a bonus. Or did both of above, you could easily do that. The flow chart of this kind of decision making is shown in this slide. Start, read employee name, amount sold, and number of new customers. If amount sold is greater than 100,000, if that is true, print name and write a bonus check. If that is false, then we test for new customers. If new customer is greater than or equal to 20, if that is true, do the same thing, print name and write bonus check. If that is false, if this is false and both are false, then we do nothing. Okay. So AMT sold is insurance sold in a week, new customer is number of new customer acquired in a week. So notice here also we do nesting. If this is true, if amount sold is above 100,000, then we write the bonus check. But if that is false, then we check if the other condition is true, that number of customers is more than 20 or equal to 20, then also we write the bonus check. Only when both are false, we don't. So this gives an idea how OR operator must work. What if we can test for amount sold or number of new customer acquired at the same time, rather than doing this nesting that we did? Oh God, this is crazy. Rather than the nesting we did. Okay? OR operator does allow us to do that exactly. And so if I test for both at the same time, amount sold greater than 100,000 or new customer greater than or equal to 20. So OR operator behaves like this, that if this is true, then also the whole thing will become true, and I'll write the bonus check. If this is true, this might be false, then also the net result will be true, and write the bonus check. Only when this is false, only then I will execute the false branch. Okay. So OR operator that is actually built in hardware behaves that way. So the way it has to work is that this scenario must exist. Scenario 1 is that amount sold is 110,000, but new customer is only 15. So in that case, this is true, but this is false, but OR operator must behave in a way that whole thing is true. Second scenario, quantitatively, is that amount sold is 90,000, new customer is 22. So in this case, this condition becomes false, but this condition is true. So OR operator must behave, our design must make operator behave in a way that this whole thing is true. Third scenario is that sold is 120,000, number of customers is equal to 2. In that case, both are true. This is true and this is true. So OR operator must behave in a way that the entire thing becomes true, Boolean true. Only in the case where amount sold is less than 100,000, this is true, new customer less than 20, this is false and both are false. Only then OR operator should behave false. Okay? So that's how it should work. And it can work if we can design it in hardware. Okay, hardware we'll talk in a minute. OR operator symbol in C# is 2 lines. It's not an I, it's a key right under the delete key on Mac. On Windows you can find it out somewhere else. So it's a OR key, separate OR key. So we can write it in C# like this. Okay, Visual Basic uses word OR. We're not worried about the Visual Basic. This is the electrical analog of OR operator. It's just an analog. Your transistors don't have this massive battery and bulb and all those things. Just an analog. So this is the electrical analog of OR operator. So this time switches are shown in parallel. So if both switches are off, actually I was looking for another diagram. I guess don't have that. Oh God. Yeah, so look at this one first. I don't know how they got out of order. So when both switches are off or false state, there is no path for current to flow, so bulb will be in the on off state also. But notice something interesting happens, that if I connect this switch, which means X becomes true, T for true. Now there is a path for electricity to flow, which will go like this. And then bulb will light up. Okay. So this goes very well with the truth table, that if one of the two switches in true state, like false true, it will result in true, true false result in true. And of course, if both are in true state, true, true, even then bulb will be in true state. Okay. So this is the truth table for OR operator. Only case where OR operator will reveal a false when both inputs are false. As long as one of the input is true or both are true, we'll get the true result. Okay. This is the truth table for OR operator. And you really should memorize this, because this is not something, this is used so often, this is not something you'll rush to your book or notes to look up. It has to be memorized. Last one is the unary, the negation operator. Needs only one Boolean operand, and it is used to write alternate or simplified form of Boolean expressions. Its best use is when loops are designed. In if and else it's not used very often, although it can be, but in loops it's used very often actually. It's also called a NOT operator. And when applied to Boolean expression, it converts a true value into false and false into true. It's represented by exclamation mark. Some people call it bang. In Visual Basic, it's used with NOT operator, NOT word. And truth table for NOT operator is in this slide here. If X is false, not X is true. If X is true, not X is false. Okay. All three logical operators and or not are actually logic gates in hardware part of the computer. The electrical analog that we showed earlier are actually manufactured into hardware that is inside a microprocessor chip, and computer engineers call them logic gates. Okay, so now I'm going to show one example of using, and I'm not sure it uses the, okay, I'm sorry, I have to scroll through this. Yeah, it doesn't use the AND operator, so sorry about that. I don't want to show this one yet. So really, crux of this talk is these three truth tables. This one for AND operator. So AND operator works in this manner, that when both inputs are true, we get false, and otherwise when one of the inputs or both inputs are false, 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 then we get a false. In case of OR operator, that's the truth table. that as long as one of the input is true or both inputs are true, we get a true results, but only time we get a false result is when both inputs are false. And in case of NOT operator, or where is the NOT? This one. It flips from false to true. If x is false, negation of x or not x is true. If x is true, then negation of x is false. And we have shown the electrical analog for two of them. So I'm going to stop this slide here, this video here, and then I'll come back with an example of where AND operator is used in a computer program. And later on we'll show you also that we can do without that too. Okay? Thanks.